Hello, I'm Vladimir Bekvansky, Strategic Architecture at PayPal.
Hi everyone, this is Deepak. I'm a staff software engineer at PayPal.
Hi everyone, this is Anisha. I am a senior software engineer in data platform services at PayPal.
So hello and welcome everybody to our talk on unified data access with Gimel. So here we are going to talk a few words about PayPal, why something like this is necessary. We are going to see what are the parts, what are the key elements of the system that we have built, how does it work, how it is used, and then we are going to see some of the next steps for our team. So looking into PayPal, PayPal is the company that has quite a bit of customers, and PayPal has been growing both organically, but also PayPal has been acquiring a number of companies through his history. And we will see in a moment why is that interesting. So the numbers that we have today are quite impressive with regard to number of customers and the amount of transactions that we are processing. So thinking about the ecosystem consists of PayPal Core, but also there are systems that we have acquired with companies like Venmo, Zoom, Simility, and so on. And as you can imagine, this number of companies and the customer transactions that we are handling is done by a variety of systems. So one of the really interesting things is a very large presence of big data systems, Hadoop systems. There are over 20 on-premise Hadoop clusters, even GPU units that are processing. And to make things even more interesting, we are in the process of migration to the public cloud. To give you some idea about the scale at which we are processing data, there are 200,000 yarn jobs a day. There are over 160 petabytes of data that we are processing. And we are running some of the largest clusters of databases in industry, from Aerospike, Teradata, Hortonworks, and Oracle. And to make things even more interesting, all of this data is being processed in a variety of different technologies. The techniques that we are supporting and frameworks include Spark. There is the conventional Hadoop, Hive, MapReduce, but increasingly BigQuery, and some of the more esoteric techniques. The data landscape that we are dealing with. If you look at the bottom part of this picture, you can see our infrastructure. Our infrastructure evolved over time from being in data center to being in multiple data centers. And eventually we are on the path of migrating to public cloud. And then all of this exists in kind of a half state between the two. So as you can imagine, quite a bit of interesting things and also requirements for elasticity in processing all these different workloads. On top of our infrastructure, there are a variety of data stores that we are dealing with. You can see in this layer, we have a conventional Hadoop Hive. There are also large enterprise data warehouses like Teradata. There is a variety of NoSQL stores like Cassandra, and even some of the more exotic systems like Druid, which is used for real-time analytics. There is also a very significant presence of streaming systems for real-time insights. And we are running a very large installation of Kafka, but also you need to provide a good search experience through many documents that we have. And of course, Elasticsearch comes in this space. And then there is also Aerospike, a key value, very fast data store that powers many of our systems. So there is this variety. And one of the questions that you have with 160 petabytes of data, it is very difficult to keep track of that. And you need to have some systems that will enable you to understand what is the data that you have, understand what type of data is stored in the stores. And you need to be able to make various queries with regard to privacy, security, data governance, data quality, and more. And for that, you can see in this illustration, the symbol with the book, UDC, Unified Data Catalog. This is the special system that is keeping track and maintaining all of the metadata for all of these 160 petabytes of data in different stores. Normally, when you are dealing with data that is highly sensitive, you don't want to allow everybody to directly access the database. And normally such systems are accessible through an API that gives you some additional advantages. For example, you can control the traffic, you can throttle the traffic, you can have very rigorous security checks when it comes to access the data. And it also allows you to do some smart maneuvers that reduce the number of fetching the data. Again, you can use some smart forms of caching. To the left, there is the compute frameworks and APIs. We have a variety of different users. Some of them will be processing analytic workflows. Some of them are dealing with calculating and managing risk. And all of these systems come with a variety of computational techniques. There is a set of Java workloads, uh, plain Java, Spring, there is Scala, there is Python, there is R, there are a couple of other solutions. So these frameworks and APIs allow our engineers to make use of this data. And here we have now a couple of interesting things. How do you expose this capability? One of the things that we have recognized as being very productive is to expose this data through notebooks. So we have a version of Jupyter, which we call PayPal notebooks, which integrates with a variety of these systems. And one of the truly essential pieces of this system is what you see as the gear to the left. This is the Gimel SDK. Gimel SDK is serving a quite unique purpose, and that is it will provide a unified SQL access to all kinds of data stores that we have underneath. So the users of the system do not need to know and understand the differences between the data stores. For them, everything will look like a plain SQL. And that benefits developers for greater productivity, or data scientists don't need to master all these different data stores, analysts, operators, and so on. All the way on the right, you can see a common set of functionality, pervasive logging. As we are dealing with highly distributed systems, we need to understand what is happening in systems. So logging and monitoring is very important. Alerting when things start misbehaving or where we recognize that there is some anomalous behavior. And then finally, everything that we do is highly secure and we operate basically in a zero trust environment. With that, Deepak can continue with the next topic.
Thanks, Vladimir. One of the big questions to answer before we go into the depths is why Gimel? As Vladimir has walked us through, payments industry has grown tremendously over the past few years. With that, PayPal has grown alongside as well. And you may have seen that our landscape has become really complex with the explosion of data. So how do you make sure the power of data is really tapped into? How do we expose all this data in a meaningful way so that we can be a data-driven organization? That's where data democratization becomes a very important theme to operate with. So just to give a simple example, if you think about accessing data in a big organization with so many different technologies, it's really cumbersome and fragile. Here's a simple example, not to go into the details of this code here, just a technology like HBase. To write a code to access data, you have to work with something like this, what I'm showing on the screen. And if you apply the same pattern to different technologies like Elasticsearch, Druid, Aerospike, Hadoop, or many of the plethora of cloud technologies that we have today, it goes all across the board, and there are multiple ways of doing this. Now, if you take this pattern and if you apply just within the realm of Spark, you can write and access data in Spark SQL. You can access data through Spark Batch or streaming or the unified APIs. At the same time, you can express this logic in the form of Scala, Python, Java, SQL, and there are many more options as Vlad before described. So let's look at the challenges in deploying a big data application. Let's say as a data engineer, we would like to access data from Kafka which is real time or near real time, and then we want to do some computation by looking up a key value store and then persist the data into maybe Elasticsearch. So here we are looking at building a code that accesses a streaming store, does some lookup on key value store, and then persists the data into a near real time sync. So the application lifecycle really looks like this. You need to learn how to deal with Kafka, Elasticsearch, key value store. And then once we know all of this, we then learn to code, optimize, build, deploy, and run it. Once we have this application that's running at scale, there is a lot of changing parameters. Let's say the compute version changed. We are operating on Spark 1.6 and then we want to move over to Spark 2.3, or we are moving over to Spark 3. Then some of the constructs on which the code has been built breaks, resulting in this whole life cycle again. Basically, the data engineer needs to go through this entire life cycle of learning, coding, optimizing, deploy, and run. Once again, if the storage API change, let's say for some reason there is an upgrade in the APIs and then we are working with a new API, that requires to go through this entire life cycle. On similar lines, there could be multiple parameters that could change. It could be storage connector upgrade, a host has been migrated and you need to redeploy some of the configs, or the storage itself changed. For example, we realize after running the workload for about 6 to 1 year that Elasticsearch is not the right solution. We want to move over to say HBase for various reasons. Then that requires redoing all of this. So the reasons can be multiple varieties, but the problem remains same. The life cycle of an application keeps going through this long process where the time required to build the business logic is probably 3 to 5%, whereas 95% of the time is maintaining the code, scaling the code, and then continuing to keep it alive during all these life cycles. So this is where Gimel comes into play. We wanted to solve this problem not for just one big organization like a data lake organization, but across the board. So multiple personas beyond data engineer can also benefit from this. Anybody with the needs to access data, be it a data analyst or a data scientist or a data engineer, or even a product manager who needs to run some analytics, should be able to access data without having to go through the learning curve or have the barriers around technology or programming constructs. So we wanted to get to a state where we build an application once by using a bunch of APIs, and then regardless of the changing parameters under the hood, the lifecycle of the application should remain constant and should not change. As you can see here, we wanted to get to a state where you build an application once, you deploy it, and during the course of the lifecycle, regardless of the underlying changing grounds, the application should continue to remain and run and meet the functional and non-functional requirements. So with that, we embarked on creating the data API, which we will see soon when Anisha walks us through it. Beyond building the data API, there were other things that we unraveled during the course of the past few years, especially the last 3 to 4 years. Once you start building a lot of big data applications and release them in the ecosystem, we stumble upon the other governance problems. You might have remembered that Vladimir talked about data governance being a very central part of everything that we do in PayPal, and also data security. So how do we solve this not at one application level, but create a solution that works for a lot of or almost all the big data applications that are running on Spark workload? This is where we started adding other unified solutions within Gimel, which would provide visibility. For example, we need to know all the applications that are running in the infrastructure, regardless of what kind of workloads they are doing. Let's say we have this large Spark cluster that runs multiple applications, and then we start deploying multiple Spark clusters over a period of time. It's very hard for the platform operators to get visibility into all of these clusters, what they're running in terms of Spark. So the unified API provides a way to emit signals that go into a common logging so that not only the store operators can get these logs and dashboards, but also the application owners can get a holistic view. Similarly, over a period of time, we evolved into what we call as the unified data catalog, which Vladimir initially talked about. So we want API-based interaction with these catalog constructs. The big data applications slowly started requiring access to these configurations, which were exposed as part of APIs through catalog. Every team started building catalog interactions. Rather, we wanted a single touch point or single API or a single set of libraries that can interact with the catalog. So we started embedding that into Gimel. And then security is ubiquitous in PayPal. We do security in every touch point possible. So we do not just rely on the securities that are natively baked into the data stores. We also want a uber secure capability where we can do things like redaction, alerting, and all of that. So we baked in that security aspect into Gimel. And with the emergence of privacy governance and the prominence of these uh, um, areas in data ecosystem, we would like to have the capability to have on-the-wire redaction of data and on-the-wire alerting when something that is classified and not should not be accessed is being accessed by applications or data developers. And finally, when you think about platform operators, usually the platform operators like to build interceptors or sniffing libraries that actually gleam into basic access patterns and then emit parameters like JMX metrics or access patterns or security patterns and so on. So if every platform operator needs to work with every data application, that's the permutation combination is really exploding and it's not literally possible to sustain that level. So having a single capability where Gimel can actually inject all these parameters for on the behalf of the platform operators to all the other application developers who do not really worry or know about these operating metrics. So this is one other problem that we faced, which we evolved and then added over. So in net, what we have is in the life cycle of an application, somebody as a data user or an application would like to access multiple stores. You can see here we have this pattern of insert into Hive, select from Kafka, right? And then join with MySQL or a key value store. The whole construct of accessing multiple stores is now either expressed via SQL, which we call as Gimel SQL, or via data APIs. And the other problems that are more broader in sense in the term of data classification, alerting, security, or platform-centric interceptors, these have been baked into the code so that the application developer or the application really worries about the business logic end of the day, while all the platform and governance requirements are baked into the library and they are taken care out of the box. The last thing that I would like to call out before I hand over to Anisha is the concept of intelligent query routing, which we are currently discussing or we have been thinking about for a while. So as you start deploying all these variety of abstractions and capabilities baked into something which is like a central engine, with the evolution of multiple stores, there is also the evolution of requirements, which change from having cold storage kind of access to hot data sets to near real-time data sets. So if you think from those perspective, let's say a user wants to access transaction data. The requirement can be in different varieties. Somebody wants a near real-time data. Somebody wants more like a 7 days worth of data, or someone wants to do a training on the transaction data. So they need 2 years, 5 years worth of data. But the access pattern is same, whereas the volume and the scale is different. How do you make sure that this kind of changing patterns in requirement is not really going to be a long pole for our users to change the access? Rather, by intelligently gleaming into the, let's say, the filter patterns, we can actually route the queries to different engines or stores. So with the help of UDC, which actually talks about the data catalog configurations, how the stores exist, all of that, with the query detecting capability in Gimel, we could combine these two together, where a user submits a query, something like select start from a transaction data, where the transaction date is last 30 minutes, that can be routed by Gimel to Kafka. Whereas select from transaction data, where the transaction date is last 7 days, could be routed to something like a caching engine, like let's say Alluxio, where Alluxio could actually be pointing in its namespace concept to Hive or some other data store, which actually has this 7 days worth of data brought into the Alluxio's cache. Whereas something that's very deep in data that has to go into the actual data store and then fetch the data for a long time frame, that could be in the form of Hive or in the form of object store, that can be routed directly to that particular store. So this is something that we've been discussing, where we could have this combination of streaming data versus a cached data that can be quickly accessible versus a deep storage that can be routed intelligently through this Gimel engine. So in essence, what that does is it takes us to a state where the access pattern for the user really does not change. By just flipping the filter, the user still gets access to the same user experience or the performance, where it can be a near real-time query against Kafka, or a query that goes to a cache and fetches the data very fast, although the data might be very large, while it could take in the order of minutes when we go into a cold storage, like Hadoop, or let's say even object store, for a longer period of time. With that being said, I will hand over to Anisha, who will walk us through the depths of Gimel code and how it works. Just before we go there, I just want to quickly share the GitHub code. Gimel is open sourced and it's out there in the GitHub. We have the links which you can look at a later point in time. We would really encourage to take a look at it, see if it fits for your use case, or even become a contributor if there is a feature that you would like to add to Gimel. Over to you, Anisha.
Thanks, Deepak. Okay, now let's do a deep dive into Gimel implementation. Okay, so as explained by Deepak before, like in order to read or write from different storages, a developer needs to research about various connectors and also how to access them in a most efficient way. So in order to solve this problem, Gimel provides a unified API, which is dataset.read and dataset.write, and also a SQL access over these data storages, so that not only the application developers, but also the DBAs and other product managers who are not aware of the Scala or Java code can access these storage data pretty easily. So to summarize, all the boilerplate code for different connectors is abstracted out, and developer can just focus on the business logic. So now let's look at an example of reading from two different storages like Kafka and Elasticsearch. Now here, as you can see, using the unified connector config, all the storage specific properties can be passed to the data unified API, which is dataset.read, through arguments. So any property which needs to be updated, or even the underlying storage needs to be updated, user just needs to specify those properties or change the storage type in these configurations and pass it to the API without worrying about the underlying implementation of dataset.read. So this is how the user gets an abstraction from with the user unified connector config and also unified data API. Now these configurations can be passed to the API in different ways through catalog provider. So in Gimel, today we have a couple of options. Like first is the simplest, which is user. User can pass the properties for a particular data set using as a JSON. But as you can see here, like every time a user wants to access, user wants to add the config for a data set in their applications, they will need to put their own config. There is no shared repository where these configurations are stored and can be used by different developers. That's why we introduced Hive catalog provider. So using Hive catalog, we store all the configurations for the data sets in a Hive catalog so that it can be shared among different developers. But still, there can be different Hive clusters, and maintaining the configurations among different Hive clusters can also be challenging. That's where we came up with an option of metadata services. So in PayPal, as explained by Deepak before, we have a unified data catalog which scans all the storages within PayPal and stores the metadata for all the datasets within these storages into a centralized repository. So that is why we provide an option to use the unified data catalog in PayPal to use as a catalog provider to get the dataset properties of a dataset. Now, the whole concept behind the catalog provider, sorry, Deepak, whole concept behind the catalog provider is you can provide your own implementation of how to fetch the dataset properties. So in your organization or company, if you have your own catalog or a metadata service, you can provide your own implementation and plug it in into the dataset API. Okay, now let's look at how a Gimel SQL actually works. So a SQL can have a select clause, an insert clause, and a bunch of set statements to set some of the runtime properties. Now, through our code gen, these SQL statements are converted into a Scala code. So the select is converted into a dataset.read call, while the insert is converted into dataset.write. And the runtime properties which are passed before the SQL statements are passed as a map argument to these APIs. Now, once we figure out the APIs, each of these APIs will call the catalog provider, which is set by a user. Like it can, as described in the previous slide, it can be user, Hive, or any metadata service. So using the dataset properties from the particular catalog provider, we get what the dataset, which storage type a dataset belongs to. So based on the storage type attribute of a dataset, we fetch the appropriate dataset object from our dataset factory. And the dataset factory consists of various dataset objects pertaining to specific storages. And each of these storage specific dataset objects contain the actual implementation of reading or writing from the connector, from the underlying storage. So for example, for Kafka dataset, it will be, for Kafka dataset, the read implementation will be Kafka consumer code, while for write implementation, the Kafka dataset would have the Kafka producer code. Along with dataset, we also have a data stream factory. So like dataset objects are used for batch use cases, but we also support some streaming use cases like streaming from Kafka. And this streaming, the dataset streaming data can be also written to a target data storage. Okay, so yeah, so as I said, each of the underlying dataset objects have their own read and write implementations. And we have used a combination of open source connectors like Spark, Hortonworks, Edge-based connector, and Kafka consumer and producer code. And also we have added some in-house implementations and optimizations for various storages. So this is how a Gimel SQL is converted into a Scala code behind the scenes. Okay, now I'll hand it over to Deepak for providing the next steps.
Thanks, Anisha. Before we go into the next steps, due to the interest of time, we have skipped past some of the internal details, which Anisha would have otherwise walked us through. But we have left those in the appendix. So if anybody is interested, you could just go through the appendix to get more details, which could answer some of the questions you may have, but we'll also be happy to take questions. So in terms of what's next, as you may have guessed, we are moving to cloud. So we would like to make sure we have a first-class support to all the cloud stores as we make this journey. And when we add the support for these cloud stores in the term of APIs, we want to make sure the SQL is also supported for the clouds stores. And one of the common pitfalls with Gimel SQL that we've seen historically is as we expose these underlying technologies from SQL lingua perspective, it's very hard for the user to understand what happens under the hood. So it almost always results in some form of runaway queries when user accidentally submits something like select star from Kafka without having any knowledge of the internals of Kafka. So we've tried to implement preempt uh, tackling of queries that could otherwise become runaway queries or long running queries or consume enormous amount of resources. And every store that we had, we have to carefully evaluate these pitfalls and add support. So when we add this support for the stores in the form of API and then transition over to SQL support, we'll need to address these challenges. On the wishful side, we have the wish to expand our support for Google's data catalog APIs so that not only Hive or user catalog is supported for somebody in the open source side, there is also support for other forms of external APIs that can be plugged in. And as we have expanded support for different kinds of technologies, relational, NoSQL, streaming, object store, we would like to also tackle the graph realms where we can make graph available to SQL users at one point in time. This is on the wish list side. We hope to achieve this sometime in the future, or if there is somebody interested in contributing, it will be really awesome to have this feature in Gimel. As we do all of this, one of the important end customers for Gimel is machine learning personas, either data scientists or ML engineers training models. So we want to make sure that we augment support for MLlib and also NLP at some point in time, so that some of the things that can be done outside of Gimel can also be baked into the Gimel libraries. With that, I would like to just pause here for um, any questions, and also thank everybody for attending this talk. Please check out Gimel repository by visiting gimel.io. At the same time, if you have any questions or if you have any suggestions or thoughts, we can socialize further on the Gitter channel that's out here. Thank you. Vladimir, would you like to add anything to close?
Thank you very much for following our path towards conquering variety of data stores with Gimel. As Deepak mentioned, it's open source, lots of opportunities to contribute and make common use of this great project. Thank you.